Okay, so tonight we're going to talk about average rate of change. And you may recognize this formula. It is, hang on. There we go. This is your slope formula. M equals y2 minus y1 over x2 minus x1, also known as rise over run. Okay, so we take the two y values and subtract them, take the two x values and subtract them, we get the slope. That gives us our average rate of change. Okay, so let's look at the graph for a minute. So here at point P, I have x1, y1, right? So this is x1, y1. And point Q is x2, y2. Okay, so we can label those points x1, y1, x2, y2. And if I look, here's my rise, goes from point P up to point Q. That's my y2 minus y1. That's how far I rose. And this is my x2 minus x1. This is my run. Okay. We could relabel these. If we wanted to use function notation instead, another way to say y1 is f of x1, which means that is the output when we plug x1 into our function. Okay, so this is the same, f of x1 is the same as y1. Okay, and if I wanted to do the same for y2, I would say f of x2. It means that that is the output when I put x2 into whatever our function is. Okay, so if we use the function notation instead, we can just change that same equation. So we're going to substitute in for y2 the f of x2 and substitute in for y1 f of x1. So we have f of x2 minus f of x1 over x2 minus x1. It is still slope. This is still our average rate of change between those 2 points. Okay, and we can find the average rate of change for this particular function, x squared. So we will plug, so here's our x values. We'll start with example A. So if I take x squared, so let's call 1 x1. Okay, so f of x1 will be 1 squared, right? I plugged 1, my x1, into the function, and 1 squared is 1. So that would make f of x1 equal to 1. Okay, f of x2, so this time I'm going to plug the 3 in. I have 3 squared, which is 9. So x2 and f of x2 are going to be 3 and 9. And if I use my formula, we can see that 9 minus 1, that's my rise, my y values, over, now I'm going to use my x values, 3 minus 1. So we get 9 over 3 for a slope of 3. Okay, we could do that again for the next two, but I think you probably get the idea. We plug the first x in, get a y value, plug the second x in, get a y value, and then use those ordered pairs to find our slope. Remember, your y value is always the thing, your output, when you put a specific x value in. Okay. Let's suppose that we did not want to have all these different variables. We got a f of x2, we've got f of x1, we've got x1, we've got x2. Let's suppose I just wanted x. I just want to use x. So instead of having all these x1s, x2s, I just want to use x. So we're going to take our original x1 and call it x. And then we're going to say this distance we move here, whatever that is h. Okay, so yes, I realize we've added a new variable, but we are going somewhere with this. Okay, that makes x2, whatever x started out, plus this distance h. So x2 now becomes x plus h. And again, if I want to use function notation, I'm going to take x. So my first point is x is my input, f of x, whatever we get out when we plug x into the function, is our output. And our second one, we've now called x2 x plus h. It's whatever the x was we started with plus some distance, which means whatever that number is what has to get plugged in here for f of x plus h. So we're plugging in the number that x plus h is in that spot. Okay? That means that this, my rise, now becomes f of x plus h minus f of x. Remember, this is still the old y2, y1. And h, remember h is my old x2 minus x1. So this is still, sorry, x1. This is still slope, our average rate of change between those 2 points. So let's look at an example of how we're going to use this, because we actually are not going to have specific numbers to put in. We're going to be doing this with functions. Oops. Okay, so the simplified difference quotient. And I'm going to start out, I'm going to go back a page, insert blank page. Okay, so your simplified difference quotient is f of x plus h minus f of x, and all of that is over h. I like to call this our roadmap. It shows us what goes where. We are actually going to have a function that we have to put in all these places. But this shows us that I have to take that function, and in spot number 1, okay, that doesn't want to write there. In spot number 1, I have to put f of x plus h. I'm going to have to calculate what f of x plus h is. Here, this is spot number 2. And in spot number 2, I'm going to have to put f of x. And then this is spot number 3, and I'm going to have to put h. That'll be the easy one, because we really are just going to put h right there. Okay, so let's look at our first function, and I believe I had just an x squared. Okay, so I'm going to do it over here so I have more room to write. So our first function is f of x equals x squared. Okay, I need 3 things to put in my roadmap. Okay, so I need an f of x plus h, I need f of x, and I need h. Well, h is just going to stay h. F of x means I take this function x squared and I plug x in where I see x, which to us means it stays the same as it is. So we're just going to call it x squared. It'll just stay exactly the same as it is. This one, the f of x plus h, is the one where all the work's going to be done. So everywhere I see an x, I have to plug in an x plus h. Okay, anytime you're doing this and you're using something like an x plus h instead of just a number, I like to go ahead and put parentheses. Let's make it look exactly like the function. Okay, so parentheses squared, right? The parentheses were where the x was. And now inside that, I have to put what they told me to plug in, which is x plus h. So I'm going to put x plus h there. Okay, now remember, we're going to have to multiply that out. X plus h squared means x plus h times x plus h. I don't get to just square the x and square the h and call it a day. We do have to multiply this out. So x times x is x squared. X times h is xh. H times x is also an xh, or an hx, however you want to say it. And h times h is h squared. Okay. So that is our simplified difference quotient. We do need to, I'm sorry, that's our f of x plus h. Shouldn't have said simplified difference quotient. We do need to combine like terms though. So we have x squared plus 2xh's plus h squared. That is our final f of x plus h after we worked it all out. Okay, so this is part 1, part 2, and part 3. Let's go ahead and put them in the roadmap. So let's draw it out. So space 1 goes first. So that was x squared plus 2xh plus h squared. Okay, so that's in position 1. Okay, in position 2, we're going to put x squared. And in position 3, we're going to put h. All right, now we're going to simplify this. So I have x squared plus 2xh plus h squared minus x squared on the top, and I have h on the bottom. On the top, you'll see that and that, the x squared and the negative x squared, are going to add to cancel each other out, and we are left with 2xh plus h squared over h. Everything up here has an h in it. Remember, you can't do this if only some things have h's in it. Every single term up here has to have an h in it. So I have, let's factor that out. So I have h on the top times 2x plus h, and on the bottom I have h. We're going to divide that out, and our simplified difference quotient is 2x plus h. Okay, we're going to try another one that's a little more complicated. Okay, so number 2 here is 6x squared minus 9x plus 4. Now remember, our roadmap says we've got to calculate what that's going to be with x plus h put in. And let's do it this way. Let's put the roadmap up here so we can see it. We've got to put in our f of x and our h. So let's calculate all 3 of those. F of x plus h equals 6 times x plus h squared minus 9 times x plus h plus 4. Everywhere I had an x, I put a set of parentheses, and I put something inside those parentheses, specifically x plus h, because that's what I was told to put inside the parentheses. Okay, before I can multiply this 6 through, I do have to square that. So we're going to have 6 times. Now we know from the last one that x plus h squared is x squared plus 2xh plus h squared minus, I'm going to go ahead and distribute that one, 9x. Don't forget this 9 owns that negative, which is going to make that a negative 9h plus 4. And now let's go ahead and distribute that 6. So we have 6x squared plus 6 times 2 is 12xh plus 6h squared minus 9x minus 9h plus 4. Okay, that whole thing that I just wrote is our f of x plus h. Okay, I do not want to rewrite that whole thing, so I'm going to draw a roadmap right here. Okay, so that is space 1, what we have written in the top. Space 2 minus parentheses 6x squared minus 9x plus 4 over h. Okay, and why did I put that second part in parentheses? And the answer to that is because I have to distribute this negative. This is like having a negative 1 out in front. Okay, so let's go ahead and rewrite this whole thing. We have 6x squared plus 12xh plus 6h squared minus 9x minus 9h plus 4 minus 6x squared plus 9x minus 4, and all of that is over h. Now let's see if we can't simplify some stuff down. Now, if we did this correctly, if we distributed our negative over here correctly, everything that's in this f of x part, so negative 6x squared, positive 6x squared, should have a buddy up front that they cancel out with. Positive 9x, negative 4, positive 4, which leaves us with 12xh plus 6h squared minus 9h over h. Again, you'll notice that everything there has an h, so we can divide out one h from each of them. Take an h from him, take one of the h's from this guy, he had 2, one h there and one h there. So I have 12x plus 6h minus 9. That is my simplified difference quotient. Okay, there should be more practice problems for you to do, and I'm happy to answer questions on your rotation day about the simplified difference quotient.